Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more, help us to share, and please subscribe. I'm begging you, make sure you subscribe. If you are enjoying the video, just subscribe. Subscribe to this platform. Now, to reach us for any comments, if you cannot, you feel like calling us or WhatsApp us or Telegram, you can reach us on this number 234-80344959990. With this number, you can call us, you can WhatsApp us, and Telegram is allowed. Okay, what I have for you now is a simple harmonic motion. But before you watch this video, we have started already, which is a circular motion. Make sure you watch the video before this, which is a circular motion. Now, when we talk about simple harmonic motion, I've explained something on circular, centripetal, and moving on the axis. You know, that's moving around a circular part or whatever. Now, I've explained those parts. Now we are now on simple harmonic motion. Now, a body is said to undergo simple harmonic motion if one, its acceleration is always directly towards a fixed point. 2, it is acceleration is directly proportional to its distance from the point amplitude. Let me put the word amplitude. Please take note of this word. It's a very powerful word. Of a simple, let me put my simple harmonic motion is maximum distance, maximum displacement of a body from its central or equilibrium. Equilibrium position. Now, that is what I'm trying to explain. These two conditions are attributes of what? Simple harmonic motion. The first one is its acceleration is always directly towards a fixed point. That is the first thing. The second one, its acceleration is always directly proportional to its distance from the point amplitude of a what? Simple harmonic motion is maximum displacement of a body from its central or equilibrium position. That is what we are talking about on this part. Now, let me quickly explain something that I just mentioned of now. The first thing is period. There must be a period that thing take. It's also period of a simple harmonic motion. Please, I don't have the time. Is the time taken to complete one circle, oscillation, or vibrates. Sure. We have done this type of circle. Okay. Now, it means my periods, which is my B. Now, period is always represented by capital letter T. Why small letter t is normal time? Anyway, when we get there, we will see it. It always equals to time taking, which is time taking. Let me just time taking, which is also equals to my small time all over what number of oscillation. Now it means we're talking about small time all over number of oscillation. What am I trying to say is that let me quickly take this time taking all over number of oscillation, number of oscillation, which is small t divided by what? N. That is what we are talking about. The second thing we are to talk about is the frequency. Now, when we talk about the frequency, the frequency also the same thing, but frequency of a simple harmonic motion. Frequency of a simple harmonic motion is the number of complete oscillation number of complete oscillation per seconds. It means my frequency, which is my frequency, which we normally write it like this, equals to number of iteration, number of oscillation divided by time taken, which is the story change here, which is I'll be talking about what my frequency equals to n all over what t. Now, mostly I consider my frequency equals to what my period inverse, which is also means 1 all over what period. Please take note of that. Anyhow, I want to do it. Don't forget that time is always in seconds. We always use this in seconds. Why this one? We use my frequency in what? In seconds. I mean, what? We use it in per seconds. We can say the unit SI unit is per seconds, or we can use it as, or anyhow you want to use it. Either one of the two is allowed. Now, those are the things we need to understand on this simple harmonic motion. Now, let me quickly explain the equations on simple harmonic motion. The equations that can generate a lot of equation. Please make sure you read extensively, because this topic is very wide. I'm just trying to do one or two things that that we can have it in 30 minutes and have it done. But it's wider than this. Please take note of that. The following can be, the following equation can be used or can be applied in problems involving simple harmonic motion. Please, simple harmonic motion. Now, let me just show you the equation. The first equation 1, my angular velocity can be equals to all over what? All over time. 2, my velocity can be equals to angular velocity, or velocity equals to all over A. Now, my A is called amplitude. Okay, I will define it later. I will define all this later. Now, theory, I can say that my angular velocity equals to 2 pi frequency. 2 pi frequency. Now, okay, I can also say that my period equals to 2 pi all over what? Angular velocity. I can also say that my 5 can also be equals to acceleration equals to squared, or acceleration equals to amplitude squared. Now, I can also say that my 6 can also be equals to my acceleration equals to alpha radius. 7, I can also say that my velocity equals to angular velocity root of amplitude squared minus x squared. I can also say that my 8, now my 8 can also be equals to angular velocity all over what? 2 pi. I can also say that number 9, my 360, we all know 360 as 2 rad, which in terms of rad, which is in terms of degree, in terms of rad, can also be equal 2 pi rad. 2 pi rad. 1 pi rad, 1 pi is always equals to 180. Why 2 pi is what? 360. My x, which is my number 10, can also be called my periods equals to 1 all over what? Frequency. My period equals to over here. And also 11, my frequency can also be equals to, this is frequency all over 1 all over period, which we have showed that earlier. Now, all these equations can be used in applying in problem solving involving what? In simple harmonic motion. Now, let me quickly explain the symbols and the definition of them. The first one, where this is known as, which I've explained earlier, angular velocity, which is rad per second. And this also, my theta, we call it angle turned by body, which is rad. My t, small letter t, time in seconds, which is, we always put x in seconds. And also my v, we all know v as linear velocity, which is my linear velocity is always equals to meter per seconds, or you call it meter all over seconds, anyhow you want to do it. Now, next one is my R, or we call it radius, and which I said amplitude, which is amplitude or radius, which is always in meter. And also we have my small letter a. Small letter a is known as linear acceleration, which we all know it as meter per second squared. Now my alpha, we call it angular acceleration, which is so rad per second squared. And the t, we all know t as my period, which is always in seconds. And my x, we all know it as my displacement, or displacement of object from center, which is of center of motion. Now the last thing they have not explained, okay, is frequency. Now my f, we call it frequency, which I've explained my frequency other time, which is always equals to 1 all over seconds, or we have it as is nothing of that. Now all these are there for you to use. Now with this, let's move on to problems or real application of this simple harmonic motion. Simple harmonic motion. Okay, I will start with let me call it application to solve problems. Now let me start with the problem number 1. Hey, why will I come from? Okay, let me come from here. The period of oscillation of a particle is 4 pi seconds. 4 pi seconds. If the amplitude of oscillation is 3.0 meter, calculate the maximum speed of the particle. Now, I have this problem to solve. How do I go? Now, the solution to this problem. The first thing I will do, my period, which is known as T, capital T, is 4 pi seconds. Don't forget that. My amplitude, which is known as my R, 3.0 meter. Now, my velocity, which is known as speed, which is V, I don't know it. Now, I will not generate any equation that are very good with the one I've listed out of the 11 equations. Now, I think this one will be of help to me, which is C equals to 2 pi all over what? Angular velocity. 2 pi all over angular velocity. Now, it means my angular velocity equals to 2 pi all over what? Period. Now, we all know what my pi is. My 2 pi divided by 4 pi. Because my period is 4 pi. This will cancel this, which is, I'll talk about 1 all over 2. 1 divided by 2. It means my angular velocity is equals to 0.5 per seconds. I mean 0.5 seconds. Okay, meter per rad per second, rather. Rad per second. Now, because we are talking about angular velocity. Now, it means I cannot continue by having my linear velocity, which is my v, equals to angular velocity multiplied by what? Amplitude, which is my r. Which I can say that my linear velocity, which is what I'm looking for, calculate the maximum speed of the what? Particle, which is, I've told you, because of we're talking a circular path or wherever, we have direction which is known as what? Velocity. Which is, I'll be having, what is my angular, which is 0.5 multiplied by, what is my r, which is my r, which is known as my radius, which is also called amplitude, is called what? It means I will be having something like this. Calculator will be of help. My v, it will be equal to 1.3 meter per second. 3 meter. I beg of you, anytime you are doing any exam, make sure you put your SI unit. It's very, very important. That is all what I need to do. That is all. That is all. No problem. That is all. Now, let me try to use another problem, another question that can really be of help to us in solving. And then we have to stop on this simple harmonic motion. Please make sure you read more, get more, and the one I've done can balance on it and get it right in any examination. Now, a body moving with simple harmonic motion in a straight line as velocity v and acceleration a when the intertaneous displacement x in centimeter from its maximum position is given by x equals to 2.5 sine 0.4 pi t, where t is in seconds. Determine the magnitude of the maximum 1 velocity, 2 acceleration. Okay, let's try to work on this question and let's see what we can get solution to this problem. Now, I have this question to work on. Don't forget that the secret of this question lies here. The secret of the question lies there. But you have to understand the question very well. Don't forget that anytime you are solving a problem in physics, ability to know where the question is coming from is very important. With that, you will know what to do. Now, this question is a body moving with a word simple harmonic motion. When you see this a word simple harmonic motion in a word straight line, leave this straight line. Don't rest on it like that. But don't forget that the problem is on what? Simple harmonic motion. And a question is given to you, which is you are good to go. Okay, in a straight line at a velocity v and what attention a, when it is what? It has instantaneous displacement x in centimeter from a maximum position is given by, which is v, where t is in seconds. Determine the magnitude. Magnitude means value. How magnitude? We have done that when we are talking about vector and scalar. Now, of the what? Maximum. The first one velocity, the second one acceleration. How do I go? The first thing I would do is that my x from the equation x equals to a sine of this, which is part of those equation listed before, which represent the what? Motion. It represents the motion of an object undergoing simple harmonic motion and can be compared with the given equation, which is my x equals to a sine angular velocity of t, which is called it equation 1, and also my x equals to 2.5 sine 0.4 pi of t. Now, we all know that my radius from the question, my radius is what? 2.5, which is also known as amplitude. And also, this is centimeter. I must to convert to what? To meter, which is to be implies 0.25 0.025 meter conversion. Now, I will now move on to my angular velocity, which is known as this. It will be equals to 0.4 pi rad per seconds. Rad per seconds. Now, the first one, velocity, which is my v. My velocity is always equals to, which is v, equals to angular velocity multiplied by amplitude, which I known as what? 0.4 this pi multiplied by what is my amplitude? My amplitude is that, which is multiplied by what is my radius? My radius is 0.025. With this calculator is allowed, which is you can turn it to you know what my pi is? 0.2 multiplied by 3.142 multiplied by 0.0245. Now, with help of I can take everything to standard form, which I'll be talking about. I'll be talking about 3.95 multiplied by 10 raised to power 10 raised to power minus 2. 10 raised to power, which was my velocity, which is to be meter per second. Meter per second. Make sure you put your unit. It's very, very important. Now, I will now move on to my acceleration, which is equation number 2. Acceleration, which is my a, equals to my A is equals to angular velocity squared all over. Angular velocity squared with multiplied by what? Radius, from the equation listed before now, which I'm knowing that my base is 0.4 pi. Okay, now pi squared of what is our radius? Our radius is 0.025. Now, once you multiply whatever we have, I think by so doing this, you can use a calculator and get what your acceleration is saying. Don't forget that your answer must be in meter per second squared. Meter per second squared. Okay, that's all what I have for you on simple harmonic motion. Don't forget, we are on with further solutions academy. Encourage us more to share and also subscribe if you have not subscribed before. Make sure you press on your subscribe button. You can meet us on this number for any question. With this number, you can call us, you can WhatsApp us, and Telegram is allowed. Thanks for watching.